Hello everyone, this is Roya and today I will be presenting update and progress of Hub Data Management Platform. Before starting the presentation, I will show you some related example. Then I will bring your attention to what is needed to develop this platform. Then we'll discuss shortly the first result of the platform's online survey. Finally, I will be talking about the plan and the design of the system. The core principle of the web platform is processing, how to choose a technology, governance, and end user. But as you can see, data plays the central role for the design and implementation of the platform. Selecting the best technology is another important factor for the development of the platform. This platform should include fair data. By fair data means that the data is findable, accessible, interoperable, and reusable. Another important purpose of this platform is to analyze the risk and assist decision maker for a better solution. All these stages are different for different user and different purposes. The main phases in the platforms are how to deal with the fair data, visualization, analysis, and decision making. So I prepared first questionnaire, the online server, to figure out what are the priorities, what can be done first, what is most needed. But before showing the result of the server, I will present you some past projects to give you a better idea on what can be expected from a WebGIS platform and geospatial technologies. I will be presenting three projects that, as you can see, I categorize them into three main steps of the platform: data, analysis, and decision. The first one is related to the data collection and acquisition. This platform called Ruma. Second one focuses more on analysis and open source data for rapid disaster assessment. The last project that is more related to the hub project is a decision support system called the risk changes, dealing with risk for now and for the future. This is an Android application that is called Rapid Offline Online Mapping app. The idea of how to build this app came from one of my colleagues and me when we were discussing on how hard it is to manage field data collection. They usually have to have the printed satellite image. In this example is using geoid with 5-meter accuracy in one hand, GPS in another hand, pen and paper to write down the details of the event and draw the event, and their phone to capture the pictures. My suggestion was that we can develop an app that you can couple this satellite image into the web app and you can enter any information while being able to easily draw any points, polygons, lines in the map, capture a photo, and of course the mobile phones recently give a really good accurate position. What you see here is a merge of what they always do, usually in the field when they're collecting the data. They enter the hazard event information in the green box, and then they draw the event by using a geolocation to see where they are exactly. And as you can see here, the accuracy of the location, their location is 12 meter. And then the data are saved in an organized structure that we call it data model. This data model presents how all these data can be connected to each other. In this example, event table is connected to photo table or damage table or to study area. Data model plays a very important role in developing a data-driven platform. This is the result of the online platform. After they successfully did the field survey and inserted all the data into the server. Later, they can easily edit, update any data that they want. The second example is a rapid disaster assessment platform. This is study for Nepal. This is an example of how we can deal with risk when there are not enough data available. Usually it's hard to calculate loss directly after a big event happens. In this example is a 2015 Nepal earthquake. However, using open data, we are able to do that. This platform uses Nepal earthquake shake maps taken from USGS as a horizontal map, and building data from OpenStreetMaps. That is around 3 million buildings extracted from OpenStreetMaps. Then calculate the loss for the entire event using expert knowledge. As I mentioned earlier, another important factor to develop a web platform is to choose the best technology. In this platform, we used OpenGeo online framework that is recently called Bundleless. This open source solution use OpenLayers, GeoServer, and PostGIS as their main tools. But I also added some other technology like SQL for the user cake to add the user data, and using a 3 layers to build this platform. This is a third platform dealing with decision making. It is a special decision support system looking at the risk for now and the future, using future scenarios such as business as usual or population growth. A main hazard in this platform are flood and landslide. In this example, you can see a landslide is somewhere in Italy. The red one are the more dangerous area. It's a village, and you can see the element at risk that they are buildings. And this platform is a really complex platform, but query and visualization in this platform are really easy. This platform is using future scenarios such as business as usual, risk and cost-benefit analysis to help decision makers by using multi-criteria decision making to deal and find the best solution. The indicators are imported from the system that they are risk and cost, or they can also be added manually by the user into the system. The system will guide them through the decision-making steps to rank and standardize the indicators, and then will show them the best alternative solution based on the prioritization. In this example, they had 3 alternatives. One of them was relocation, that they had to relocate the whole village because of how dangerous the area was. Another alternative was the engineering solution, that they had to build some dam on top of the area. And the third one is a mixture of some relocation and some engineering solution. And in this example, based on doing different decision-making rules, the engineering solution got the best solution and result. As you see, data model play, again, a very critical part in this platform. This is what you see is just a quarter of the main data model that I was responsible for this decision-making part. And data model is very, very complicated. However, the outcome of presenting the result can be very easy to query, find, and compare the different data and the result. This is why we need to have fair data management platform. From these last 3 examples that I presented to you, we can see to design a web platform, we need to develop a data structure, we need to choose the best technology and architecture, and we need to find a way to query and visualize our data. Data models define how data is connected to each other and how they are processed and stored inside the system. It will help for the improvement of data quality, query, and analysis of the data, and will ease the visualization of data and help decision making. This is why data model is the most important thing in the platform. Data visualization is the act of taking information data and placing it into a visual context, such as table, map, and graphs. Data visualization make big and small data easier for human brain to understand, and visualization makes it easier to detect patterns, trends, and outlier in group of data. Visualization will help decision making to understand a better idea what's happening with the data, and it will target different audience for having different visualization, and it can easily handle large amount of data. So the importance of data visualization is better analysis, quick action, identifying patterns, finding errors, understanding the story, and exploring business insight. Here I'm going to present a visualization example for the weather data. These data are taken live from open data from the internet. The data are available in JSON format or XML format. These are the web services format. I will show you later what web services data are. And this is one of the visualization of the data. In this example, the bar chart are presenting temperature, wind speed, and humidity. The red one is the temperature, humidity is the blue one, and the green one is the wind speed. And we can easily put all these different multi-attribute data visualization in one map. This was type of a visualization. I was planning to use it for wildfire. And this is another example. In this example, we see all these data are taken from internet as a web services. The red dots are the active fires using modest satellite images taken from NASA for that day, and the bar chart is showing like the other example, the weather data, temperature, humidity, and wind speed. And usually they believe the hot, dry, windy weather that we were here planning to calculate the index for the weather data will cause the fire. This is the second example of weather, and it's presenting the time series data. As you can see here, that for the time series data, the data can be presented for the next 15 days or the past 30 days. And here you can have the wind speed, wind direction, air temperature, maximum and minimum for the whole day, dew point, humidity, and the hot, dry, windy fire indexes. This is the area in Canada. I selected different points, and you can see the more you go farther, you can see different dates here. And this is a normal glyph visualization for the wind and the data, and the darker the color is, the red is the warmer the area is, and also the more humidity of the area. This is another example that I'm planning to present you. This data from the environmental data government, it's a water quality visualization. They use the web service data. And I tried to explore a lot. This data presented in the XML format, and I found this data not really fair because it was really hard to find the data. And every time you want to do the query, you need to refer to some weird ID number. I'm not sure where those come from. NW51, as you can see here. It was not only because of that. For example, when we wanted to look for ammonia, you will see the collection of the data from 2000 and 2010, and there were gaps between these data. For example, 2008, 2001, 2003, and I would say that this data, I think they did not do the quality check, because some of the data, maybe it's not so many in this example, but in some of the example, the numbers were really out of the area that they were collecting. For example, if the ammonia that they were collecting was between 1 to 20 or something, sometimes all of a sudden you would see number 50. But I could try to present it in a web platform that you can see it here. Some of the data from the northeast area that they were collecting, and you could see the ID code, the area, this thing, north thing, and the label, and if this sampling point in status is open or is already closed and they're not collecting any more data. From this past two visualization and presented, you understood that we could present the data in time series using multi-attribute data. Uh, Do we need to present the data in 3D or 2D? As you can see here, all these things need to be discussed with the whole group. So I would need some example, and I would need to see what are the solution. Your solution is to presenting and visualizing your data to the end user. How do we present it so that the public and other expert can understand it? How can the data can be presented most appropriately? These are the things that is make it important to prepare the next questionnaire and the server to ask for the feedback every time in each step of developing and design of the platform. The objectives of the first online server are to understand what your research stands in the Hub project, what has been done already, uh, how to prioritize the steps for developing the platform, and finally, to design user interface for the platform. I asked the people from the Hub project people to attend this online server. I received 39 entries, responses to the server, where the majorities were from UK, Colombia, and Ethiopia. I wanted to understand what are the major research they're doing in the Hub project. People are working in different expertise. The majorities are working in water risk, water management, water quality, water value, and water security. So the system, the platform will focus in these five categories. Later on, I try to ask them what type of formats they're using. Since this is a data platform, one of the first questions were about the geospatial and non-geospatial data format. Majority of people use shapefiles and raster tip for geospatial data format. The next one comes KML and NetCDF. And for the non-geospatial formats, they're using PDF or Word, text or CSV, that they're Excel formats, and images. As you remember, I was presenting you about the visualization and how important it is in the platform. So I wanted to know that what type of visualization usually they need. So I asked if it's maps, graphs, charts, or table. And you see, most of them, they use more or less all this type of visualization, maps, graph, and tables. That is the most focused. A very small percentage of people, they say that they need to present to the end user written analysis and stories. So this is about the pre-processing and the quality check when I ask. The first step in the data management is processing of the raw data. Almost 90% of the participants claim that they need to process the data before presentation. They use different tools to do that, but main one are GIS software, Google Earth Engine, R, and SPSS. 79% mentioned that they will do quality control for the collected raw data. This is really important. When we want to have a fair and proper data management platform, we need to do the quality control for all the data, and we have to remove all the outliers from our raw data and process data. 92% need secondary data for their project. This is huge. We need to come up with practical solutions. Secondary data and open data are not always reliable and accurate, and we need to be sure that we all use the same source. I also asked them if they have ever downloaded any data from the following website, Hydrosheds. Apparently, this is going to be one of the main website for the draw basins, but half of the participants answered no. After collecting the data, processing them, and do the quality check, we need to analyze them based on the purpose of the research. Majority of the people use GIS software. Why? They also write their own codes, especially in Python and R. Since many researchers write their own codes to do the analysis, we decided to ask what programming languages they prefer. Majorities were using Python, R, and MATLAB. Apart from format of the data, I needed to know what type of data they were dealing with. Almost half of the participants working with large data. The system should be able to perform big data. Interestingly, 65% of the participants using time series data. So they're collecting the data in different time. And this is important when it comes to the visualization. Presenting time series data is always a big challenge, especially if there is gaps between the data. Between the collection of data. As you can see, majority of participants claim that this is the case. Earlier, I explained why data structure and data models, we can also call it database, are very important, actually play the main role in the data management and platform design. Despite that almost half of the participants do use databases, but these people, they just use normal Excel table to deal with their data management part. So this is a little bit more challenging to design the data model for the whole hub project. You remember I was presenting you some visualization related to weather data that I call them web service data. And they were coming in JSON format or XML format. In online server, I asked if they have ever heard of the WebGIS data. This type of data can be very useful as a secondary data, especially those data that need to be updated daily, like weather data. And 65% of participants never heard of this technology, and only 36% use web services data. Web services data come in different formats. Most participants have experiences using raster, CSV, and camel data. However, the most common web services formats, especially in a geospatial platform, are XML, JSON, and web map services and web feature services. One of the final questions were about the end user. Users play the most important part in the platform. If you remember from the beginning, it was one of the main phases in the development and the design of the platform. Based on the different user, we will need to design different user interface. For example, public user need more simplified result of the analysis in a way that is easy to understand. This is the case for specialists. This is in other fields as well, when they don't understand your field. We should be able to translate our result in a simplified presentation. Apart from stakeholder and specialists, public are one of the major users for our platform. This was one of the last questions I asked, that when they can give us the data to help develop the platform. As if you remember, the data was in the central part of the design and implementation. We need a complete study area, including data and outputs from typical analysis. We ask participants about the availability of data or a case study area. Most people confirm that they can provide their data within 18 months or by end of the project. This is a little bit challenging. The platform need to have a data model, and data models need to have data to be able to design it. But I was able to talk with some people, and for this part, by now, I have some data quality for the water data from the water quality from Ethiopia that will help to start developing a data model and to continue for the implementation of the platform. And this is showing the available platforms that is already been developed in the hub project. And I wanted to know if we can merge any of these things with the hub platform. This was the list I came up at the end based on the survey. Most of the result of the question were as expected. However, I was expecting more engagement and more participants. The platform plan is divided into 3 phases. The first phase that is almost done, um, and a little bit might be some delay in it due to COVID and the cyber incidents that happen in the university, is to find the problems, available technology, architecture, requirement, what data we're going to use, what server we're going to use, we select the technology. The second phase is going to focus on the implementation, visualization, data model, example from water quality, water risk, water value, and then develop the modules. And then finally, the last phase is going to be the test and refine for all these water management risk, quality, value, and then come to decision analysis. From the phase one, so we have the server. The server is used. There was some problems due to the cyber incidents, but it's a Linux. It's good they gave us a 1 terabyte hard disk. It's 32 gigabyte. I mean, if we're gonna do analysis, we might need some more RAM, but for now this is good. I still got no data to be able to use for the platform, but there are some people that promise me they will give some data, as I mentioned, for the water quality. The user interface will be designed based on the data that I will receive, hopefully in the next 2 weeks. And then, yes, the technology has been selected already. This is kind of the primarily design of the platform. The platform involves geospatial and non-geospatial data. This data will be uploaded to the system and be processed and analyzed for different users. The different visualization gonna be for the stakeholder and specialist or public. And the visualization comes into a map-based interface, graph interface, and table interface. And then after they process the data, upload the data, process and analysis, they can link to the risk and decision modules. This is just a primary design for the decision and risk modules. The user will calculate the risk based on available data that is provided by the platform. This include hazard, vulnerability, and element at risk. At later stage, specialists will define alternatives or future scenarios where can affect our decision-making metrics differently based on special qualitative and quantitative indicators. The platform will then help the decision maker, will guide the decision maker to do special or multi-criteria decision analysis based on their decision rules, preference, and ranking. Then will form the decision matrix. Since we always have uncertainty in our data and data collection, platform will assist using insensitive analysis and finally select the best alternative and do the best decision making. And yes, this was the end of the project, and thank you for listening and watching my presentation. If you have any comments, any feedback, please don't hesitate to contact me. And if you have any data, I will be really happy to have some data from your research and to understand what you're doing in the Hub project. Thank you. Stay safe.